In this video, I want to show you how to find both the mean, it's right here down at the bottom of the screen, the mean and the standard deviation of a discrete random variable. Let me just quickly point out something to you, and that is the expected value. If you ever see on your homework assignment to find the expected value of a discrete random variable, it's the exact same thing as finding the mean. So finding the mean and finding the expected value are exactly the same. The formula is the same. They both mean the same thing. No pun intended. Alright, so I'm going to show you how to do this, but using Microsoft Excel, using some technology. Now you can also do this with a TI-83 or an 84 calculator if you want to do it out that way too, but I'm just going to use it. Excel here to show us how to do this. I have a separate video on my YouTube channel, poysermath, where I do the exact same problem, these exact same random variables, 4, 5, 6, 7, with the exact same probabilities, and I work all of this out by hand. Right? But in this video, I'm going to show you how to use Excel to do the exact same thing. You know, using technology like this is wonderful if you have a lot of random variables. Now we only have 4 random variables, 4, 5, 6, and 7, so only 4 random variables here. But if you had a whole bunch more, if you had 14 or 18 or 20 of them, or if the probabilities were pretty big, then you could use Excel pretty easily, and it works it out fine. So I'm going to show you how to use Excel. Now, a couple of things that you need to know. These are my random variables, 4, 5, 6, 7. That's what X represents. This column here, column B, is the probability of attaining each of these random variables. So the likelihood, the chance, the probability of getting a 4 is 5%, or 0.05. Right? And the probability of getting a 5 is 0.25, or 25%, etc., etc. Now, for this to be a true probability distribution, this column here, right, that I'll highlight, this column here, these 4 values should always add up to be a 1. In fact, I'm going to do an auto sum. I'm just going to see this capital sigma here. It just says auto sum. So I'm putting the cursor, right, I'm clicking in the cell right underneath this last value here. And if I click on this once here, notice that equals sum and B2 to B5 shows up automatically. I didn't even type that in. So Excel is looking at all of the numbers that are above this cell and saying, hey, you probably want to add all these up, don't you? And I said, yes, I do. All right, so notice that an equation, any type of formula in Excel, starts with an equal sign. Sum is the name of the function, and in the parentheses here, we're adding up cell B2 to B5. So I'm just going to hit enter. That's all I'm going to do. I'm literally pushing enter on my keyboard, and yep, sure enough, it added all these up and I got a 1. Now if this is not a 1, you might as well just stop the program right here. Just stop the problem. Don't even work this out if your probabilities do not sum to be a 1. Special note, each of these probabilities has to be a number between 0 and 1 as well. Right? Each of these has to be a number between 0 and 1, or else they're not true probabilities. It can't be greater than 1, nor can it be less than 0, or negative numbers. Right? You can't have negative probabilities. Okay, so now that I've verified that it's a 1, you don't really have to do that, but now that I've verified that it's a 1, let's actually apply this formula here to find the mean. All right? And I really wish there was a bracket around this x times p of x right here, because the formula says to take each of your x values and multiply by its probability. So I'm going to type that in right here, x times its probability. All right, and what I just typed in is just really it's just a title. It's just letters. It's not a formula at all. Notice it didn't start with an equal sign, so it's not generating anything. It's really just the title of this column. Okay. So here's the actual formula. The actual formula is equals, take your x number and multiply it by its probability. Right? In my case, I've got x in A2 and its probability in B2. So I'm just asking Excel to multiply those two things there together, and when I hit enter, it gives me an answer of 0.2. Now the beauty of Excel is that I don't have to retype that formula every single time. I'm just going to grab, right, I'm clicking on cell C2, which has the formula in it for this particular row, and I'm just going to grab the bottom right corner of that, do you see it turns from a white plus sign right into a little skinny black one there? Right, and I'm going to drag it on down, and it automatically generates the correct formula for each of these rows. That's pretty cool. Okay, so now I've got I've got 5 times 0.25, there it is. I've got 6 times 0.30, there it is, etc., etc. The formula says to do one more thing to find the mean. Right, capital sigma, that's a sum. So I'm going to put my cursor right here and sum up that column. And I get a sum of 6.05. Now that value is the mean. Let me highlight that. You don't have to do this, but I'm going to highlight that number because that is the mean. Not mean. There we go. Alright, so our mean of 6.05, that is the number that we would expect to show up on average if this experiment is repeated over and over and over and over again. Alright, so we found the mean. Now, why did we find the mean? Well, it's part of the problem, probably, but even more so, we're now going to go find the standard deviation. And do you see that if we use this formula for the standard deviation, or this one for the standard deviation, whichever one you want to use, either one requires that we know what the mean is. Alright, so we first have to find the mean. Let me also point out, in my opinion, using this second formula here is probably better than using the first one here. It's just a little bit shorter and a lot less work. Plus, it only requires that we take the difference of the mean squared once, whereas this formula over here requires that we take every x and subtract the mean and then square that and then multiply it. So it's too much work. This first one is a lot of work. I'm just going to show you how to use the second one here. And again, I wish there was a bracket that encapsulated this x squared times its probability and then close bracket right here. That's what the formula really should look like. Alright, so here it goes. What this says is to find the standard deviation, we have to square all of our x's, multiply it by its probability. Alright, I can do that. So we're going to take x, we're going to multiply it by itself. Alright, that's going to take care of the x squared part, times its probability. Alright, again, what I just typed in is just a label, that's all. But I want to show you that what I'm going to do here is I'm going to take this x times itself, right, that's the squaring, and times its probability. That's this thing here, the p of x. Right? And now that I've got that, this is 0.08 for the first one, I'm just going to repeat that all the way down. I've got my values now. Do you see that the next part of the formula says to sum them all up? Right? So this minus x squared over here is not part of the summation. It's not part of the summation. Only the x squared times p of x is being summed up. So I'm just going to auto sum this column right now, and I've got a sum. Right? I'll call this here sum. And the formula says, okay, now that you've got this sum, subtract the mean squared from it. All right, we're going to do a couple more things too. We also have to square root, but we'll get to that in a second. I've got a sum. We're going to subtract the mean squared. Well, I already know what the mean is. Mean is 6.05. Let's stick over here in this cell over here. Let's stick the mean squared. That is 6.05 times itself. All right, and again, this is the beauty of Excel. You can just type in the formula and let it figure out what the number is. Alright, now don't round that off either. Just leave it exactly as it is. Okay, now, where it says sum right here, where I said sum in cell F2, I'm just going to say, hey, go grab this sum over here. Sorry, I typed in equals, and I'm going to click on this. So whatever is in D6, I want it to show up over here as well. So that 37.45, you could type it in if you want. I was just getting fancy. But what we're going to do now is I've got the mean squared, that's my 36.6025. I've got this summation. Now I have to take the difference of the two. Maybe I'll do that right here, right? I'm going to say, hey Excel, take the sum and minus this other guy, right, 36.6025, and come up with an answer. But that's not quite my standard deviation. In fact, that number right there is the variance. Right, it's the variance. But if you want the standard deviation, you have to do one more thing, and that is you have to square root this difference here. Alright, so I'm going to do that in this bottom cell here. So I'm going to say equals sqrt is the name of the function in Excel to do a square root. And so I'm going to say, hey, go square root whatever's in cell F4. And I've got my answer. Let me put this in a different color. How about green or something like that? Alright, so I've got an answer of 0.920,598, and it probably goes on and on forever. But you can have Excel do the rounding for you, right? So if on my math lab, or if your instructor or on a quiz or a test says, hey, round this off to just 1 decimal place, you can do that by I'm clicking on this thing here and I'm just saying, hey, look, just keep clicking until you get to just 1 decimal place. Or if you wanted 2, it would be 0.92. If you wanted 3, it's 0.921. Alright, so you can have Excel even do the rounding for you if you want. And in fact, I'm going to leave it just like this because that's how I showed it in the separate video where you work this out by hand. Well, I hope that helps.